to this universe. And the loss of entanglement ends all time. All events execute. I guess that's my assumption about light. And that's the paradox right there. Is there a way to travel faster than the speed of light? Well, obviously, I think there is. Here's an interesting idea. Everybody talks about, why does an atom spin? Why is the planet spinning? Well, I guess I thought about that. Matter is not dark energy, and it's not the fifth element of outer space, this energy field that's there. So matter vibrates at a certain frequency, and so does the universe. In this interaction, or this, like having the fire under the pot of water, you have an atom, and its internal parts are vibrating, and you have outside of that atom the frequency, or these waves generated that are in the ether. And because this is vibrating and the atom vibrates at a different speed, I think that they would have the tendency to start to rotate. They're locked in the energy field, a bent space-time bubble. And then the energy that's inside would start to spin because of the external force and the differences in the vibrations. Now, this is something that probably could be tested in a simple forms, but I think that that's basically the reason why they spin. And I think if you looked at the solar system and they try to say that gravity is, why is it so weak? It isn't very weak. I think if you sort of looked at the energy levels required to dislodge a planet from an orbit, would be very similar to how much energy might be required to remove an electron to a different ring in its orbit around the nucleus of an atom. So, I guess they talk about these bonds how strong they are. I think a lot of that energy comes from the mixture of dark energy and matter, that energy field that surrounds an atom. It's the breaking of this field that actually causes a nuclear detonation of these. All energy is kind of like a photon. It's at a different energy level, and they have a different spectrum, but it's still a photon. And you can't see this because you can't see dark energy. I mean, you don't have a sensor that's built out of dark matter. Would dark matter exist? Of course it would exist. I think that it's highly probable that this could exist. It doesn't exist here. If it does exist, it's totally invisible to us. And well, that's the situation that we're in. You can't measure something. It's like, how would you do something that's invisible? You know what I'm saying? You can see what it does, but you can't see much more. I say, I think where these photons came from is basically they come from an interaction between the space-time curvature interaction with matter, this vacuum energy, and actual dark energy particles are probably part of an atom. They're just not seen. They interact, but they're impossible to view. And when the atom is split, this energy field that holds an atom together at this level is obliterated, and the force that's stored is transferred to photonic energy, gamma rays, high intensity photons. As I said, like, there's the Earth, there is space-time pushing in on every atom on the Earth. There's an equal and opposite reversal. It's a push towards the Earth, equal and opposite reaction the other direction, which would kind of force galaxies to push apart as viewed. It is, I guess here, as of today, like you have an up quark, a down quark, and electron, particles in a table. But a photon is not really part of an atom. Like, you don't see it actually, they don't even know where it came from. So that still goes along with this idea about space-time, this field that's created around everything and even an atom that holds it together. It's created by this interaction between matter and ether. So I would say you can't see light only straight on. I would even say, like, in a solar system, that there's an interaction of dark matter energy and matter. And if you could actually go to the edge of the solar system and you had a probe to look back in, I think you might find that there's energy created at that edge, because of course you're going to have more of a space-time bubble around the whole solar system too, as you would around the sun. But it might create photons that are measurable and more than the sun could only produce. So, like, you would have to look for to read from outside of the solar system, like a mathematical calculation on what the sun generates for photonic energy and what seems to be coming from this interaction of this matter and the fifth element, because those light photons would only be seen that way, not towards the Earth. They would be attracted out, and that field would be very surprising to measure, to see like what energy level there is actually there, because everything is heading towards heat death. So these reactions that we see are using energy. Everything is moving forward in time and energy is being expended, and things are aging or becoming more entropy as you go forward. Yeah, dark energy, it's basically a carrier wave. Yes, it's totally independent of matter. It has a frequency to it. It's everywhere. It's the reason why time exists. It's the reason that light only travels at 186,000 no matter what you do. It's not going to go any faster, because light doesn't have a jetpack. It doesn't have a warp drive built into it, and it doesn't have any means of automatically traveling 186,000 miles per second. The only way that it could possibly do that, if it's, say, a hybrid particle that is attaching itself to the carrier frequency of the universe, or that ether or dark energy, the fifth element, a very important part of everything that's not understood. I got some other unusual ideas. The creation of the universe. No Big Bang. There never was a Big Bang, right? But there could have been two massive energy fields. Matter, ether, and in the center, where they meet, ta-da, creation, out of nothingness. Just as matter is created at the edge of a black hole.